Okay, so the question says, find an explicit formula and then find the 203rd term. That's what this means, the 203rd term in that list. So what kind of a sequence do we have? Arithmetic. So we have a difference of 3. And since it's arithmetic, our base formula, kind of the framework of our problem, this is not in your notes anywhere, these are extras. I'm just doing for review. So squeeze them in somewhere. Or don't do them, I don't care. Explicit formula, we're going to start with our framework, and we're going to plug in our first term, which is 5, and our common difference, which is 3. And then if there is any kind of simplifying that we can do, we do it. We can simplify in this problem because we have a distributive and then collect by terms. So there is my explicit formula for that specific sequence. Good? Now, find the 203rd term. Well, that's super simple. All I need to do is plug in 203. So I'm going to get 3 times 203 plus 2. So it looks like the 203rd term is 611. Could we do the same thing if our sequence had been geometric? Yes, we just wouldn't be using this formula, we'd be using the geometric formula, right? Okay, now, given this, we're gonna find the second term. We wanna find A sub 2. So what are we gonna let n equal? If our job is to find A sub 2, we're gonna let n be 1. Because if you put a 1 in there, if you let n be 1, this is gonna say A sub 2 equals 4 A sub 1 minus 10. And we know A sub 1 is 6. So this is gonna be 4 times 6 minus 10. So the second term is 14. And then, you know, I need to put more up here, but could we find the third term then? And so on, whatever we wanted to do. Okay, good. Now, back to the notes. We are on 6B. 6B. We have a geometric sequence where the second term is 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, and the 8th term is 192. So, first, 1, 2, 3, 4, 5, 6, 7, 8. Yep, got it. You know, it's geometric. Which means what? Multiply. So I need to somehow multiply, and end up at 192. So I'm going to start with 3, and I'm going to multiply, we call it the common ratio, 1, 2, 3, 4, 5, 6 times, and I'm going to end up at 192. Now there's no great mystery there, guys. I'm going from the 2nd to the 8th. Isn't that 6 steps? Yeah. So I'll divide by 3, so r to the 6th is 64. Dividing by 3. Right? Now what? Sixth rooted, absolutely, I'm gonna sixth root it. That is a perfect, I almost said perfect square, it's a perfect sixth root. Anybody know what the sixth root of 64 is? 2. So R is 2. Now, question said, find the first term. So I want to find this term right here. Now remember, that tells me that I multiply by 2, right? So if I'm going backwards, I'm going to divide by 2. And so this number would be 3/2 or 1.5. Is that all right? Okay, 9/4 homework is going to be due on today's Friday, right? Do you want
Isn't there
Tuesday?
2 of them? There's 2 things. There's just number 1.
Oh,
That's why I was asking.
probably
Yeah,
should
that's why I was
sign
asking.
one there. Oh, maybe they're both going to be there.
Whoa.
Oh, come on.
Whoa. Hold your horses.
Total. Oh, no, we're not ready for 9, we're not ready for the second one yet. We can only do the first one. So 9/4, number 1. What we do.
Give me that crown.
We need to practice a little more on limits before I do 9, the next one. Do we have class on Monday?
We do, and then we don't Tuesday.
The next one will be okay? So, I'll make a little worksheet, it's a little more limit practice, we'll do that on Monday. But yeah, the first one is due on Tuesday, okay? The first one is due on Tuesday. Okay, now, today, we're looking at the first part of 9/5, and the first thing I see is this wiggly thing. Have you ever seen that squiggly thing before? Oh, some of you have seen it. What? It means it's a summation notation. That's exactly what it is. Where have you seen it, Omen? In physics class, it's a summation. All of you, well, most of you for sure have seen it though, if you've ever driven down a street that had a bunch of sorority houses or fraternity houses. Because that is a letter that shows up, it's a Greek letter, and it shows up in a lot of sigma phi epsilon, for example. That's a sigma. That is a Greek letter sigma. To the mathematician, it is exactly what Alden said. It means summation. So what exactly am I summing? Works real easy. Start right here. N equals 1. Put 1 in, and what do you get? What does this equal right here? 5. All right, now put 2 in. What do you get when you put 2 in? 7. And then put 3 in. And then put 4 in. So you start with this number, and you chug, 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 until you get to that number. That's your last one. So I'll put 4 in and get 11. So those are the numbers that I am adding up. With your sigmas, you start with whatever's on the bottom, and it does not have to be 1. It very often is, but it doesn't have to be. You start with that bottom number, and you go all the way till you get to the top number. And then you just add them up. So what is that? 32? Yeah. Easy. How about B? Can you do B? First number I'm adding is 1. Is that right? Now, one thing that is always confusing to kids is when they, I should say always, often, when we see we're going from 2 to 6, and I'll say, okay, how many terms is that? People will just subtract and say 4. But actually, how many terms is it? When we actually plugged in the numbers, how many is it? 5. Does that make sense to you? The term 2, second one, is actually counted. So when you say 6 minus 2, you're taking that 2 out, but you can't take the 2 out. The 2 is part of the problem. So there are actually 5 terms represented here. And the sum is 15? All right. Right, you do the last one, C, or the last one on this page, I should say. Did you get 30? All right, let's turn the page. Yeah. All of a sudden, I'm starting to see a problem, potential problem. I know what this means. This means add all of these up, starting with 1 and ending with 100. And I can do that. I mean, I can write that down. Let's see. The first one would be -1. The second one would be 1. The third one would be 3, and so on, all the way to 197. Remember, we start by plugging in 1, and we end by plugging in 100. Now, what's the issue? It's gonna take forever. Easy, we can do it, it's just gonna take forever. Luckily, you know how we had formulas to find the 203rd term? We have formulas to add these up also. So 2 new formulas to add to your list. This is your arithmetic sum formula. Notice it has an S. Sum. So this sequence is arithmetic. Would you agree with that based on what I wrote out here? So this is the formula I'm going to be using in a minute. But I'm going to go ahead and give you the geometric one. Notice the R there, that's your clue, that's geometric, it has a ratio in it. So again, you don't have to memorize those, I'll give them to you, but you need to know this is your arithmetic sum, and this is your geometric sum. So whenever you're adding them, which will always be the case if you're sigma, if you got a sigma, you're adding, like Alden said. We can add in other problems too. All right, so let's see if we can figure this out. How many terms am I adding up? N is how many terms are involved in the problem. I'm starting with 1 and going to 100. How many terms is that? 100. That's 100. Count on your hands. 1, 2, 3, 4, 5, all the way to 100. That's going to be 100. So there are 100 terms. So my formula says 100 over 2. What does this stand for? First number, which is -1. And then what does this stand for? Now remember, that n, and that n are all exactly the same thing. So what does that say? A sub 100, which means the 100th term. And the 100th term is 197. So remember how this seemed like it was gonna take forever? We've got what, 50 times 196, that's gonna be our answer, whatever that is. 9,800. Pretty cool, huh? All right, let's look at the next one. You got these written down?
Not quite.
Sigma means sum. I know I'm gonna use my sum formulas, but I don't know which one until I know what kind of sequence I've got. I've got a guess, just looking at the way that's built. But to check, let's just write out a few terms. So I'm gonna put in 1. Now you guys be careful. What happens if you put in 1?
Zero, which means.
You get 0, 3 to the 0, and 3 to the 0th is 1, so that just equals -2. Now put in 2, and now this is a 1, so -6. Let's do one more, just to make sure it's what we think it is. If I put in 3, I put in 1, then 2, then 3, I get -18. Is that enough for you to see what's going on?
Yes.
We are multiplying by 3, which means it's geometric. Which means if I'm gonna add it up, I'm gonna use that formula right there. Now, how many am I adding up? I'm starting with 1 and counting all the way to 15. So how many is that? 15. Formula says first term minus first term times ratio to the 15th over 1 minus the ratio. That okay? Little suggestion, don't have to do it. I always, before I start typing, I go ahead and clean up my denominator and just make it -2. I always do that first because otherwise dividing gets a little bit tricky. Do not worry about all the negatives. The calculator can handle it. See if you type it right. Did you get -14348,906? Did you get that? All right, let's look at F. That was just E. Now we're doing F. Now we got these, so I'm gonna erase these off of here. Uh-oh, this one looks a little different. What's different about it? It's infinite. It's infinite. Why is it infinite? There's no stopping point. So we're still gonna start with 1. Okay, we can do that. If we put in 1, we have 6 times a third, which is 2. And then if we put in 2, we have 6 times a third squared, which is 2/3. Royce, you okay?
Yeah.
So I'm gonna plug in 3. So then I have 6 times 1/27, which is 2/9. Now, this could keep going as long as I wanna take it. Can you tell what's going on there though? Is there enough there for you to figure out what's happening?
Zeros to zeros.
Well, the limit would absolutely be 0. Now remember, we're summing this. We're adding these up, and clearly these aren't gonna add up to 0. But as I look at what's happening to the terms, eventually they're gonna get down here so small, it's gonna be about 0. So, and the reason that is, of course, is because that number is less than 1. We talked about that the other day. We'll practice more on Monday with that. But we are actually multiplying by 1/3, aren't we? Are we multiplying by 1/3?
Yes. Yeah.
So this is geometric, the ratio is 1/3, but I can't use the formula I gave you because the formula I gave you has an N. And this has no stopping spot. So I have another formula. S equals A sub 1 over 1 minus R. That is your infinite geometric series formula. So if you want to add up something infinite, that's your formula. And you know it's infinite because it doesn't have a lid. But there's 2 caveats to that. You can't add up everything. It has to be geometric, and it has to have a ratio less than 1. Okay? In other words, like Eli noticed, these terms gotta be getting smaller. Okay? If they're not getting smaller, you can't add it up. And they have to have a ratio, they have to be geometric.
You have to memorize these formulas.
Someone tell him?
You're gonna get a sheet,
No.
but you have to know which one's which.
Alright, thank you.
We've talked about that.
Well, no, you talked about the last
You're good,
one. I didn't know if it.
Stand
You
down.
didn't know
Stand
that.
down.
Give you the other ones and not give you these.
Well, I don't know.
Boys, this is true definition of
Okay,
digging.
alright.
Huh?
So,
That's
let's stop.
definition of digging right there.
What was our first term?
First one, Colin. First
Two.
one.
Yeah,
It's 5/3. Is what I get.
The ratio is 1/3.
I got 5/3 for the answer.
So that's 2 divided by 2/3.
Yeah, maybe
That's 2 times 3 halves.
I don't know how I got 5/3.
I don't either.
I got 5/3 too. I plugged it in on the calculator.
I'm on my calculator 2 divided by 1 minus 1/3.
Okay,
Can't do that?
no, because when you do this, guys, pay attention. I told you already, I know we only did one example of it, but I always clean this up first. Because when you do 2 divided by 1 minus 1/3, the calculator is a machine that is programmed for PEMDAS. So he's gonna take 2 divided by 1, which is 2, and then he's gonna subtract 1/3, which is how you got 5/3, but that ain't right. If you're going to leave it like this, you gotta put parentheses. That's why, I don't wanna mess with that, that's why I always do that subtraction first. Okay? There's only one right answer, and it's in 5/3. So 2 divided by 2/3,
How
which
did
is,
2 divided by 2
okay, that,
And you have to do that still?
Yeah.
Okay, that's what it is.
that's why, look what I did over here to the side, I just remembered keep change for left, I didn't have to worry about it. Okay, quick story, real quick. One of my very first years of teaching. No, it's a good one. One of my first years of teaching, Daniel Michael's mom was my student. She came in one day and said, Mrs. Ford, we were watching, my dad and I were watching TV last night. They said something on TV that can't possibly be right. We need to talk about it. I said, okay, what is it? She said, if you put one checker on the first square of the checkerboard, 2 on the next square, 4 on the next, 8 on the next, 16 on the next, and so on. By the time you get to the last square of the checkerboard, you'll have enough piled up to reach the nearest star. The sun is 10 to the 7th, 93 million miles away, technically the nearest star. She said, no way. Because there's only how many squares on the checkerboard? 64. So by the time you got to the 64th term, you'd have enough checkers to reach the nearest star. Well, kids, isn't that geometric? So the 64th term will be 1 times 2 to the 63rd, using one of the formulas we had before. All right, so 2 to the 63rd, big number. That's how many checkers I've got. I'm gonna divide it by 3. I'm saying maybe 3 checkers, make an inch, I don't know, even argue, it doesn't matter. Make it 4, make it 2, whatever. I'm gonna divide that by 12 to get how many feet. Divide that by 5,280, and that last term represents 4.85 times 10 to the 13 miles worth of checkers.
Wow.
Amazing.
It kind of seems like this thing my friend Charlie told me that
Absolutely.
Absolutely.
Absolutely. If I remember, I got another story about geometric sequences are amazing. I got another story that I remember.
That's something long.
Homework 1. Homework is due on Tuesday. 9/4/2 will be due on